This is a presentation I did for the community in Denton to help them decide if they want to have gas-fired power plants in their city. When we're talking about natural gas, we're really talking about methane. This is a cartoon of all the infrastructure required to bring natural gas to our homes, to our vehicles, and to export it to other countries. All of this infrastructure is required, and there are leaks from every stage. There are emissions and air pollutions at every stage of this infrastructure. And remember, this is just a cartoon. When we're talking about emission numbers, it's important to know what they're talking about. Are they talking about the entire supply chain, all the upstream, midstream, and downstream emission points, or are they only talking about one part? Some Denton City Council members only talk about this part when they talk about emissions or air pollution. They seem to have forgotten about all the rest. This is the infrastructure that will be required to bring natural gas to the power plants. In addition, there will be drilling, that the emissions from drilling are not even counted, fracking, and line compressors. Line compressors are needed as the wells decline, as the production declines. They need line compressors. They also need gas processing and treatment plants. Those are like refineries for natural gas, and they will need compressor stations. We don't know what the emission rates are going to be from the processing and the compression because no one has talked about that in Denton yet. Remember that all emissions are estimates to meet the permit by rule that the TCEQ gives. Nothing is actually measured at the source. The TCEQ has a spreadsheet that engineers can download and come up with the calculations of what they think the emissions will be. Oh, and periodic emissions are authorized to exceed the steady state limits of the rule, but we don't know what periodic means. This is a TCEQ permit by rule, and these are the amounts that are permitted for the facilities to release. 250 tons per year of carbon monoxide or NOx, 25 tons per year volatile organic compounds, sulfur dioxide, or inhalable particulate matter, and that inhalable particulate matter gets lodged in your lungs and can get lodged in your brain. There's additional particulate matter and 25 tons per year of any other air contaminant except, and part of the exclusions for that are greenhouse gases because Texas doesn't really care about greenhouse gases. All of these emissions will be times 58 plus because Cornell University took the information about the Denton power plants, the proposed power plants, and they calculated how much fracking it would take to feed natural gas to those power plants. They came up with 58 wells plus. As the wells decline in the Barnett Shale, the decline rate is very rapid. It's about half the production after the first year. So as these wells decline, they will have to continually bring on new wells, which will be an endless stream of drilling and fracking for as long as these power plants are functioning. So let's look at the permit by rule in the real world. Argos Central Facility was permitted for 144 blowdowns a year. In reality, they had 501 blowdowns in 2011. By February 3rd, they had exceeded their permit. So the community thought that surely the TCEQ would give them a violation or caused them to have a higher level of permit. But that didn't happen. The operator had some engineers calculate estimates for the 501 blowdowns, and somehow, miraculously, those emissions fell within the range of the original proposed 144 blowdowns. So that is how a permit by rule works in Texas. Now, the EPA did give this facility a violation of the Clean Air Act, which is a pretty big deal. Air is the most likely pathway of exposure for people. Exposure is certain because of accidents, leaks, and allowed emissions. The pathway can't be broken because there's no alternative source of air. If your water gets polluted, that is horrible, and although it is undesirable, it is possible to get an alternate source of water. But unless you want to wear scuba gear around, it's not really possible to get an alternate source of air. Stopping the exposure is nearly impossible unless you want to ban it or relocate. So you're left with trying to minimize the exposure. The problem with being exposed to this kind of air pollution is that it's a mixture. It's a lot of different kinds of pollution, many different chemicals released at once, and the presence of one agent can increase the toxicity of another agent by several fold. In Argyle and Bartonville, they did baseline testing, and they detected 7 of the 84 chemicals TCEQ tests for. Later on, after fracking was going, they did follow-up testing. The TCEQ found 65 different chemicals on the lot where the high school band practices, and that's a half mile from the facility. So your 1,000-foot setback is not going to be protective. The parents wanted to know, what is the increased risk when chemical exposure to our children intensifies from 7 chemicals to a cocktail of 65 chemicals? No one can answer that because that science has not happened yet. So let's talk about methane and climate change. We broke our atmosphere. You can see how much methane has jumped up since the industrial age. And I had to add this little red tick mark here because in 2014, methane rose at the highest rate for a decade, and now methane in our atmosphere is at 1,833 parts per billion, and it needs to be back down here at maybe 500, 800 parts per billion. We have tripled the amount of methane in our atmosphere, and half of the methane is coming from natural gas and petroleum systems and coal mining. How much methane is leaking into our atmosphere, or as those of us who live around it know, call it venting, spewing, blowing, and blasting. There's 2 ways that the amount of leakage is looked at, and one is guesses and one is measurements. And this is not by any means a comprehensive list. I just took a few examples. NOAA measured emissions in Denver, and they came up with a 4% leakage rate. They also measured emissions in Uinta Basin and came up with a 9%. Purdue measured in Pennsylvania, and they said it was 100 to 1,000 times more than EPA estimates. EDF measured in Texas with the cooperation of industry, and they found 50% higher than EPA estimates. This is all important because leakage must stay under 2.8%, or some say 3%, or some say 3.2% to see any climate benefits over coal. Now the guesses are taken mostly from EPA estimates. The EPA estimates come from industry. Industry voluntarily supplies the estimates for the amount of methane they think they are leaking from their facilities. Most of the estimates range in the 2 to 3% of production. So the answer to how much is leaking is we don't know. And the problem with that is there is risk associated with uncertainty, and that risk is to the future of our children. So how hot is methane? Or what do leaches have to do with fracking and climate change? Global warming potential is a measurement of how much heat a substance can trap in the atmosphere. Carbon dioxide has a global warming potential of 1, and everything else is measured against that. Methane has a global warming potential of 21 over 100 years. That means methane will trap 21 times more heat than CO2. But wait, scientists changed that to 25. Oh wait, then they changed it to 33. And they changed it a couple more times, and then they said to hell with it, because young methane is hotter than old methane. And we don't have 100 years. So the scientists on the Intergovernmental Panel of Climate Change studied it, and they came up with a global warming potential of 86 for methane. That means methane will trap 86 times more heat than CO2 over 20 years. So using fracking to stop climate change is like using leeches to stop anemia. It's not going to help. And you may have seen this if you follow me on Twitter or read my blog. And if you don't follow me on Twitter and you don't read my blog, see what you're missing? But it gets worse about methane and climate change, because industry, to alleviate our fears about how much water they were using in fracking, they let us know that combustion of methane creates new water. But last week, the World Meteorological Organization and Global Atmosphere Watch released a study that said water vapor and clouds globally lead to an increase in thermal energy that is about 3 times that of long-lived greenhouse gases. Long-lived greenhouse gases are CO2 and methane and other gases. Well, water vapor has spiked in our atmosphere, and it's making a vicious cycle. As the earth gets hotter, more water vapor is created, and more water vapor traps more heat, which makes the earth hotter. So the combustion of methane creating water vapor is something we really don't need right now. So to recap, methane combustion creates CO2. CO2 warms the planet. Oil and gas production allows massive leaking of methane into the atmosphere. Methane brings hitchhikers with it that harm health and the climate. Methane warms the planet 86 times more than CO2 on a 20-year time frame. Methane and CO2 are long-lived greenhouse gases. Methane combustion also creates water vapor. Water vapor warms the planet 3 times more than CO2 or methane. 1/3 of all the oil and gas reserves, half the gas reserves, 80% of the coal has to stay in the ground, or our children aren't going to have much of a future. And this is what the scientists are telling. We need to keep it in the ground. So there you have it, Denton. You need to make a decision on whether or not Denton builds 2 new natural gas-fired power plants. And that's all, y'all. Thank you.